That's okay. Have you read the HDLC stuff? Okay. So the last part is about routing protocols and how uh, routers choose to route addresses and things like that. So we'll take a look at that in Packet Tracer, and then we can talk about ARP, and we'll look at that, and then you can finish the chapter later. Okay. So let's get started. So the stream is up now, and let me name the stream. How do I change the lesson 1 with Hanny? Okay, so the name of the stream is lesson 1 with Hanny, but that's because obviously this isn't lesson 1, but I'm going to be putting these videos on YouTube so they don't get deleted after 2 weeks, so you can go back and look at them whenever you want. Alright, so the first thing we're going to talk about is HDLC frames versus Ethernet frames. Whenever, as you can see here, let's see, I've got some differences put up. So Ethernet frames and HDLC, they're both layer 2, but they work with different, one is used for WAN connections and the other is used for Ethernet connections. So if you look at this little chart that I've made, you can see on the left side they've got the Ethernet, and then the right side is HDLC. So they have some of the same properties. You can see that they've got the MAC addresses in there, they have the flag, which is the preamble, the addresses, payload, which is the data, and FCS. So you don't really, if you want to look at the chart, it gives you information about each one of these inside the book. It tells you what each one of these means. So you can learn about what a flag is, what your address is, the control. Control isn't really used anymore, but it's just there for old time's sake. And then type is only used on Cisco. So Cisco proprietary means that Cisco is the only company that puts two type bytes inside the HDLC frame. So I've drawn this poorly drawn little network, as you can see here, for how, and I'm going to ask you how each one of these sections, what type of frame would be sent. So do you remember what a lightning bolt represents in a network diagram? Yeah, but do you remember what kind? It is a leased line. So leased lines are just internet connections. Oh, if I can grab it. Okay, here we go. Just move this over here. So leased lines are basically just these connections that people buy on the internet, and they're used to transmit over WAN. Do you remember what a WAN is? WAN? Yeah, wide area network. So the most popular wide area network is the internet. So whenever, let's say PC1 over here wants to talk to PC2. So whenever it sends information, the first thing it'll do is there's an Ethernet frame here. So Ethernet frames are going to be black lines. And then whenever I draw a red line, that's going to be a WAN. So two Ethernet frames are sent, and then once it gets to here, on this connection, an HDLC frame is sent, which is over a WAN. So HDLC will connect to here, will be the type that's sent from here to here. Then once it gets back over to this side, it's back into the LAN, so it's going to be an Ethernet frame, and then finally an Ethernet frame to send to the laptop. So that's just what this is what HDLC is. It's used for WAN connections. And I believe the book it doesn't really go into detail about HDLC in this chapter, it just gives you a brief introduction. So now we're going to look at a different type of WAN connection called EO-MPLS, Ethernet over multi-protocol labeled switching, I believe. So here, instead of a lease line, is connected to a cloud. So this cloud is an EO-MPLS cloud. And this is where now if data is sent, instead of using HDLC frames, it's still Ethernet frames. So it'll be Ethernet, Ethernet, Ethernet the entire way through. So we you don't know the specifics of what is inside the cloud. It could be another router, it could be some switches, it could be a bunch of different things. But that's not really what you're concerned about. Whenever you configure EO-MPLS, you're really only concerned about these two devices. So these are the ones that you're going to configure. They'll connect to a cloud, and then they'll be able to send data to each other. So that's the difference in EO-MPLS and Ethernet, or sorry, and HDLC, just on a broad overview. So that's pretty much the gist of the HDLC versus an Ethernet frame. Of course, the book has like more detailed information that I definitely recommend you taking a look at once you read through this chapter. And this is like I said, broad overview stuff, so the book goes into things later, so if it's kind of confusing right now, it'll be solidified later. Alright, so now we're going to take a look at Packet Tracer. If I can get it to load up. Alright, so let's switch over to Cisco Packet Tracer. Okay, so with Packet Tracer, we've used it before a couple times. So we're just gonna throw some routers on here, throw a couple switches, and then throw some end devices. Some of these laptops or PCs. Connect them all up. Okay, so now we're going to talk about routing. So let's say we've got two different networks, right? So we've got 192.168.10.0/24 network over here. And then on this side, we have a 192.168.20.0/24 over here. So if you remember, whenever you are configuring laptops and things like that, I don't know if you ever went and did any labs, but if something is within the same subnet, so let's say this PC is .1, 192.168.20.1, and there's another PC of 192.168.20.2, these two can talk to each other. But they won't be able to talk to this PC over here because he's in the 10 subnet. So what routers do is basically you'll come to a router and you'll say, okay, I want to talk to the 10 subnet. And the router thinks, okay, I know how to get to the 10 subnet. I have to talk to this router. So this router will use, let's say, .1, and this one's 192.168.100.2. So this router will this router will take a look at the packet and say, okay, to get to the 10 subnet, I need to go over here. I need to talk to the 100.2. So it'll send it to 100.2, and then 100.2, if it has the network and its address and its range, it'll send it to the PC. But let's say there's another router, it'll send it to that router, and then that router will send it to the PC. It's basically just making a path and choosing where to send the packet to reach its final destination. So we're going to actually configure that really quick. So we're going to go into this PC, click on desktop. Oh, I almost forgot to change it. So PC 0. So we're going to go to config on the PC, and our gateway is going to be 192.168.20.1, because that's going to be our router. Our router is going to be 20.1. And if you click on your interface, this is where you're going to put your IP address, 192.168.20.10. It's going to be the IP address for this laptop. And it puts the subnet mask automatically because it's a 192. So we're good on that, and then we're going to get into our switch really quick. Going to go to the CLI. Then we're going to config T. We're going to go into interface 01, which is where the laptop's plugged in. We're going to go switch port mode access, switch port access, VLAN 20. So it doesn't exist, so it's going to create it. Then we're going to go into the gig 01 and create a trunk port. So switch port mode trunk. And let's do that for my own benefit. So we've got the switch configured. That's basically all we need to do on the switch. Now we need to talk into the router. So we'll go router, CLI. So the first thing with the router, it's very different from the switch. So we need to type enable and then config T, same way. But this time gig 00 for, because that's what's connected to our switch. So we'll go into interface gig 00. Now routers, the ports are automatically shut off when you first get started. So you have to type in no shut. So it turns the port back on, and you can see right here it just says port changed to up. I'm actually gonna Alright, so once the port is up, routers, instead of configuring on the actual port, if you're trying to connect to a switch, routers have to do something called a sub interface. So you'll do interface GI 0/0, and then you'll put a period or a dot. And then this number can be anything, but it's usually a good idea to make it the same number as your VLAN. So I'm going to put dot 20. So now this creates the sub interface GI00.20. So once you're in there, you can type encapsulation, because this is used to tell it that, hey, we're going to encapsulate using .1q, which is the protocol that trunks we're going to be using to encapsulate data. You're always going to use .1q. It's pretty much the only one that's used today. So if you hit question mark, it has different options, but we're going to just use .1q. And then finally, if you hit a question mark, it'll ask you for the VLAN ID. So this is VLAN 20, so we'll put VLAN 20. Now that we've configured our encapsulation, we have to give this port an IP address. So this is the default gateway that our PC configured, right? So 192.168.20.1. Then we have to put a subnet mask. Same thing as the other one, 255.255.255.0. So now we've created this IP address. One more thing we need to do is we need to go into the other interface, 01, and this one, we're going to go ahead and put a description on it. Connection to router 1. So this one's router 0, the other one's router 1. So now whenever we log into the switch, we know, okay, this one goes to router 1. So we'll put no shut, so the port's turned on. Then we have to give this one an IP address. We don't have to create a sub interface because this is connecting to another router. So we'll type IP address 192.168.100.1. 255.255.255.0. So this router is now configured. So we'll exit, and I'll go ahead and go into the other router and configure that one. Yes, so subinterfaces are used to if there's a trunk port connected to it. So that switch uses a trunk port to connect to the router so it can send all the data. So you would need a subinterface to encapsulate it. So subinterfaces is where you put encapsulation.1q, and that's basically telling the router, hey, there's a trunk port here, so we need to be a trunk too. Alright. So in this router, we're going to do the same thing. We're going to go into interface GI0/0, and we're going to type no shut, and then we're going to type interface GI0/0 dot. This one is .10 because this subnet is the 10 VLAN. So same thing, encapsulation .1q 10. Then we're going to give it an IP address 192.168.10.1 because this is the default gateway. And give it the subnet mask. So this is finished, and now we're going to configure 0.1 no shut on here. We're going to give this one an IP address 100.255.2.5.255.255.0. So now that we've configured both of the ports, we can look at the routing table. So the routing table will tell you how many routes it has and how many networks it can talk to. So if you look on here, if you type show IP route, it lists a bunch of codes up here at the top. So this will just tell you what type of route is going in, and this down here tells you the routes. So C stands for connected routes. So connected is the 10 network, and local route is also 10.1. So the direct connection to your IP address is on to this IP address is on gig 00 subinterface 10. So this one has two networks on it, basically the full 10 network and then just the IP address. And then you see the same thing for the 100 network. But since this is a router, it's supposed to have an address to get to the other. It's supposed to have an address to get to. One second, I'll show you. It's supposed to be able to get over to this PC on the left, but there's no route to it. So we have to go back into the routers and we have to configure routes. So don't really, if it's, you don't really need to know how to configure routes just yet. So I'm just going to configure them pretty quickly so we can talk about it. But so IP route, and then if you hit a question mark, it'll say the destination of where you want to go. So the destination prefix is 192.168. We want to go to the 20 network, 20.0. So you don't put an actual IP address of a device, you put the network IP address. So the network IP address isn't actually used on a device, it's the first address that's in a network, so 20.0. And then if you hit question mark, it says the destination prefix mask. So this is the subnet mask of this destination. So ours is 255.255.255.0. And then finally, if you look up here, it says the forwarding router's address. So this is just the next router in line. What is the next IP address to get to it? So this would be 192.168.100.1. So we create that, and the route to 20 is now created. So if we go back to show IP route, you can see now we have a static route that tells us, hey, if we need to get to the 20 network, we have to talk to 192.168.100.1. So that means we have to talk to this router here on the left. So the left router is going to tell us where the 20 network is. But now there's no information to get back because this router needs a route in it. So we're going to go into the first router, router 0. And we're going to do the same thing, but instead of configuring it to the 20 network, we're going to configure a route into the 10 network. So IP route 192.168.10.0 255.255.255.0, and then finally the next hop address 192.168.100.2, because the 100.2 router has the information to get us to the right route. or sorry, to get us to the right network. So you hit enter, and then if we look at show IP route, we can take a look and we see we've got a static route telling us how to get to the 192.168.20 network. Does that all make sense? Okay. So I don't think I configured this other switch, did I? Let's see. Here we go, I'll switch it over. Show, run. Yeah, I never configured this other switch, so this wouldn't have worked because I didn't configure this switch. So config T, interface GI 0/1. We're going to switch port mode trunk because this is the one connected to the router. And then interface FA 0/1. What kind of port is this one going to be? Fast Ethernet FA01. What kind of port is this? It's connected to a PC. What's that? Access port. You're right. So switch port mode access, and then switch port access VLAN 10. So now we're going to test our configuration. I'm going to go into the PC1. So PC1. We're going to go into the command prompt. First, we're going to ping our router 192.168.10.1. It's not working. Looks like I made a mistake. See, now we got to do some troubleshooting. So we're going to look at our router 1 configuration first. So I've got 192.168.10.1 with the subnet mask of 255.255.255.0. That is on interface GI01. So we're going to try to ping Oh, hold on. I don't think I gave the laptop a Yep. So that might be why. So if you type ipconfig, it'll show your IP addresses and your default gateway and your subnet mask. Here I don't have anything. So of course it's not going to work. So I'm going to go to the physical or the config. I'm going to set the gateway to 192.168.10.1. Then I'm going to go to the fast Ethernet and I'm going to set the IP address to 192.168.10.10. So this is actually pretty common. Like whenever you're at work or something and something's not working, you can look at the IP address. Usually it won't show all zeros. If it can't talk to anything, the IP address will start with 169. So if you ever see 169 as an IP address, you know there's a problem. So IP config. So if you see here, we got our IP addresses now. So now we're going to try to ping, and we're able to ping our router. So now we're going to try to ping 192.168.100.2, and we're able to ping 100.2. And then finally we're going to ping 192.168.20.1, which is the other router. Oh, not working. Oh, and now it's working. So sometimes it takes a little second for everything to work out. 20.10. Did I make it .10? I don't even remember. Yep, 20.10. So the first ping is kind of looking for the device. It doesn't quite find it, but the second one's able to find it. So if you take a look at page 69 in the book, it'll show you basically what we did, but without the actual configuration. It's got a little flow chart that says, oh, the destination is in another group, which is another subnet. So it sends it to the router. The router says it's in router 2. Router 3 says, oh, it's in router. Router 2 says, oh, it's in router 3. And router 3 says, I know where it is. So it sends it directly to the PC. If you turn the page, it shows the exact same thing, but with Ethernet and HDLC packets. So the last thing we're going to talk about is let's see here. ARP. ARP. Address Resolution Protocol. So Cisco Packet Tracer doesn't have like the full functionality of devices, so I don't know if this is going to work on here. So if we do show $ARP, ARP, yep, it works. So if we do show ARP, you can see that 192.168.10.10 is our PC, but then it has the MAC address of that PC listed here. So now that the PC has talked to the computer one time, it kept its hardware address in here, so whenever it sends information to the switch, it automatically has the MAC address listed. Same thing with it has its own ARP or MAC address listed, and it also has the other routers MAC address listed. So I think that's it for today. We went over a decent amount of stuff. We're going to take one more look at, I don't think, can switches do ARP? Yeah, show ARP. But nothing's listed. Show IP ARP. Yeah. I've only worked with layer 3 switches, so I don't know if layer 2 switches actually use ARP. But that covers today. We talked about HDLC versus Ethernet. We talked about how to configure routers. We actually looked at the routing tables of routers to see the routes that were input into them. And finally, we covered ARP. So, good lesson. And if you have any questions, you can send me a message or you can ask me tomorrow. Sound good? Alright, I have a job interview in 4 hours. So, we'll see how that goes. Yep, thank you. Alright, I'll see you later. Bye. You're welcome. Bye.